Tesla's new electric battery is set to destroy the EV industry. 16 years have passed since engineer Martin Eberhard revealed his innovative custom-designed sports car before a sea of investors, journalists, and possible buyers in Santa Monica Airport hangar. The Roadster, as it was called, had a lot of futuristic engineering, but nothing about it mattered more than the 6831 lithium-ion battery cell overloaded into the rear compartment, which gave the vehicle its range and speed. The battery system is the secret, Eberhard described at the time, behind our 4-second 0 to 60 mph acceleration. Eberhard and his collaborator, Marc Tarpenning, named their new electric vehicle company after Nikola Tesla, and 2 years later, in 2008, the Tesla became the first commercially manufactured lithium-ion-powered vehicle to hit the auto market. Lithium-ion, or Li-ion, was a huge step up from the nickel-metal hydride (NiMH) batteries that had been powering most hybrid and electric vehicles, including the wildly famous Prius. Lithium battery energy density signifies a Li-ion battery can store a third more watt-hours per kilogram than NiMH batteries can, which means they last longer and weigh less. But the lithium battery still has important drawbacks. It depends on important critical materials, not just lithium, but cobalt, copper, graphite, and nickel, that are obtained by hacking into mountains or by pumping scarce desert groundwater into ponds, then waiting for the water to evaporate and leave the material behind. The Democratic Republic of Congo gives more than 70% of the world's cobalt, often by exploiting child labor under dangerous working conditions. Other minerals come from countries with which the United States would favor to loosen economic ties, including Russia, which supplies 20% of the world's dwindling stores of nickel, and China, which provides virtually all the graphite utilized in EV batteries internationally. By 2029, only EVs with 80% of their minerals sourced in the US or its allied nations will be eligible for the full tax credit. We don't necessarily have the ability to get some materials unless we go to places that are defined as not acceptable, says Ben Prochaska, executive director of the Electrification Coalition, a nonprofit that operates to move transportation away from fossil fuels. Very soon, we may not be competent at getting certain materials at all. China, for example, has threatened to keep its graphite for its own prodigious battery industry. Market analysts forecast the global demand for lithium will surpass supply by 2030. We have got to find out a different way of making batteries, states Prochaska. With state and federal authorities and incentives forcing auto companies to prioritize battery-powered vehicles in their fleets, and volatile gas prices moving more purchasers towards zero-emissions transportation, automakers and battery companies are hurrying to do just that. They are operating to grow different ways to make batteries, while decreasing costs, enhancing energy density, which translates to all-important longer driving range, and weaning the industry off of what the US government calls foreign entities of concern. Batteries that replace so-called conflict materials with domestic materials have higher level of beyond research and development to their testing phases. A battery that minimizes cobalt in favor of nickel, magnesium, and aluminum is already in commercial production. Many companies are working on solid-state batteries, which utilize no potentially flammable liquids, and plans for gigafactories that are committed to battery manufacturing in the US abound. A battery cell can be thought of as a sandwich, a positively charged cathode and a negatively charged anode around an electrolyte that passes ions from one side to the other. The electrolyte is almost always a vicious organic solvent. The cells in Li-ion's battery have all those components, but structured a little differently. You can think of our battery cells as a French dip, Lytle says. The electrolyte permeates the whole thing. Solid-state batteries, in contrast, use no electrolytes at all, swapping it out for a polymer or ceramic that provides the same function but without the flammability risk of organic solvents. Gasoline-powered cars catch fire more readily and more frequently than EVs outfitted with Li-ion batteries. But Li-ion batteries are uniquely vulnerable to the phenomenon called thermal runaway, where the burning cell can throw off heat faster than it causes it. As firefighters in Florida learned after saltwater-soaked Teslas caught fire following Hurricane Ian's storm surge, it takes an awful lot of water to put out a chemical fire, up to 40 times as much as it takes to extinguish a gasoline car fire. In fact, battery researchers are more likely to be successful in commercializing silicone anodes than they are to perfect a solid-state technology, some experts state. Silicone has potentially twice the energy density of graphite, which is usually used in lithium-ion batteries, and it's much more widely available. Silicone's feedstock is sand. A silicone anode battery could be made available in just a few years. The main problem has been silicone's tendency to expand as it charges and discharges. The volume changes almost 300% if you're doing it to its maximum capacity, states Brian Cunningham, a technology development manager with the U.S. Department of Energy, and it creates a lot of mechanical strain on the entire structure, making it unlikely the battery could survive a commercial vehicle's requisite charge-discharge cycle. We're engineering solutions to reduce that stress and strain, he says. A better idea than discussing bleeding-edge technologies, GM's Martin says, is to simply look at which materials store the most energy at the least cost and are available without tearing up Indonesian coastal villages for nickel or relying on authoritarian regimes. Lithium-ion battery prices are volatile, but right now they cost somewhere around $150 per kilowatt-hour. For cost parity with gasoline-powered engines, that price has come down to at least $100 per kilowatt-hour, although some automakers are eyeing $60 per kilowatt-hour. There are many ways to get there, but no one knows when it will occur. All of this is still very much in a lab setting, Martin states. 97% of all nickel reserves in the US are situated within 35 miles of Native American communities. In the real world, the people who purchase vehicles will be the ultimate arbiters of successful battery technology, the DOE's Cunningham says. What matters is making the battery that will outperform drivers' expectations for range and acceleration at a cost that makes the electric versus gas-powered debate moot. At some point, we'll hit this crossover point where battery electric vehicles are cheaper than conventional ones, he states. He doesn't much care how we get there, solid-state, silicone, or some other innovative battery design. The U.S. Department of Energy, he notes, is chemistry agnostic. In October, the DOE announced $2.8 billion in grants for 20 different companies operating to bolster the production and processing of critical materials in the U.S. Another round of funding for specific ventures will be announced in January. Jigar Shah, director of the Loan Programs Office at the DOE, states in a video pointed at researchers and manufacturers that the IRA added $40 billion to the agency's loan authority to support the Advanced Vehicle Manufacturing Program. The goal of the program is really to onshore and reshore the supply chain for the automotive sector as we decarbonize here in this country, he said. On December 12, the DOE awarded a $2.5 billion loan to Ultium Cells, a joint venture between GM and LG Energy Solutions that will produce low-cobalt batteries at 3 U.S. facilities. Whatever the disadvantages, the acquisition of lithium, no matter where it is discovered, probably won't slow down. Not only does our dependence on gas and diesel engines injure the climate and our lungs, says the Electrification Coalition's Petroska, it's a major national security risk. We continue to export billions of dollars on an annual basis to countries that don't share our ideals, he notes. Battery technology may not be in every sense benign, but we have much greater control over how we generate electrons than we do over where we get our oil. The future of transportation, he says, is electrification. The debate is over.